We're going to look at finding the nth term of a sequence, and this sequence we're looking at is a linear sequence, also known as an arithmetic sequence. And I'm going to show you on a diagram how this is similar to linear graphs that you might have studied previously. So usually on a graph we have the x and the y axes, but for nth term we're just going to slightly rename these axes to help us out. So instead of x we're going to have n, and instead of y we're going to have something called t of n that looks like this, t n, which means nth term. Okay, so I'm just going to plot these points, and what I'm looking at is this n is 1, 2, 3, 4, 5. So my first term is 2. So my first term is 2. My second term is 5. My third term is 8. My fourth term is 11, just off, and I can't actually plot my fifth term, it's not going to fit on there. But hopefully you could see that I can join these up with a straight line. Now if this was a graph, usually we'd have it as y equals mx plus c. But we don't have this in quite the same form anymore, but it's very similar. Instead of y we'll have tn equals, we normally say, well I suppose you could even say mn plus c. You could even use the exact same letters, it doesn't really matter because these are going to become numbers in a minute to help us out. So the important thing here is the n and the tn, meaning the nth term, meaning, for example, the 10th term would be if I went all the way up and kept going until I hit the green line that will be extended, what term would it be? And we're going to look at how to find the value of both these numbers. Now ordinarily, to find the value of c, you find where it intersects the y-axis, and in this case where it intersects the tn axis. And it's quite hard to see from this particular graph, but I'll show you don't actually need to if you've got this information at the top. This is normally our intercept, and this is normally our gradient. But of course gradient is just the change in y divided by change in x. In other words, every time you go one along, how many do you go up? So I'm going to rewrite out this information here in a way which can be helpful for us. Okay, so I've written out my 5 terms which I know and which value of n they correspond to. I'm also going to add an extra one in, which is the 0th term. Now of course that doesn't really make sense of, you have a first term and a second term, but what is a 0th term? But we can use the pattern to help us. So let's look at a couple of things here. So my sequence each time, hopefully you can see, is going up in 3s, which would mean this would go down in 3, meaning I would have -1, which is why it went down here, and that would be -1 there. Okay. And now, actually, I've got all the information I need for my nth term, because this c value is my green value here, so that's -1, and my m is my gradient, means how much do I go up by each time? Well, I can say I go up by 3 each time. So my rule would just be 3n minus 1, and that is tn. And that is because my gradient is 3. Every time I go across 1, I go up 3. Across 1, up 3. And it starts at -1. And if I wanted to find my 10th term, I'd put n equals 10 in, and my 10th term would be 30 minus 1, which is 29. Okay, let's look at a different example. So we've got another sequence to find the nth term of, and I'm going to draw my little table again. N, and the term which corresponds to it, 1, 2, 3. I've only got 4 this time, 7, 11, 15, 19. I'm also going to put in my 0th one, and my pattern this time is add 4. So to take away 4 to go that way, which would give me 3. So my nth term will be given by 4n plus 3. Okay, and I could use this to find any term. So if I wanted, for example, the 50th term, the 50th term would be 4 times 50 plus 3, which would be 203.